I'd like I'd like to thank you all for taking time to attend the session. So we are going to cover a lot of important information in this session today, and I am hopeful that you will find it valuable. Before we get started, I just want to take a moment to introduce myself. My name is Naazir Uddin, and I am working with Oracle India as a principal QA engineer. I have over 15 years of experience in software quality assurance with a focus on functional and non-functional testing, as well as manual and automation testing. And I'm passionate about helping people learn and grow. I also learn a lot of things and would like people to take advantage of that. And I also like to learn from others. So from this session, my expectation is at the end of the session, all those participants which are attending this session should get something from this session at the end of the session. So I feel that it would be worth, and my session is successful if you guys get something out of this session. And I'm really excited to be here, and I'm looking forward to share my knowledge with you. I know it's a weekend, and you people took off the time from your busy schedule and like a day on which a lot of people do their own stuff and relax. So I'll try to keep this session short and informative as possible. The objective of this presentation is to make us all aware about what is performance testing, which is one type of software testing, along with the basics of software testing. So to understand, to go till software performance testing, we have to understand some basics. So in first few slides, I'm going to cover the basics of software testing. Then we will jump to what is performance testing and what is the tool and how to test any application for performance. Okay. At last, I will share about the roles and career opportunities in this. So let's start with the session. So to understand the performance testing, we need to start with what is software testing. So here I have summarized in just 2 statements. Checking the product or application does what it is supposed to do. This involves verifying that the product or app meets its requirement and perform its intended functions correctly. Like, for example, software tester might check that a website search functionality return the correct result, or a mobile application login process work as expected. For example, when we click on when we enter the user ID and password and click on the sign in, it should allow us to log in. So this is the example of what it is supposed to do. Okay. Coming to the second part of the first point, checking the product or application does not do what it is not supposed to do. This involves verifying that a product does not exhibit any unexpected behavior or undesired behavior. For example, to understand this, software tester might check that a software application does not crashes when it is given an invalid value, or that when a website does not allow a user to access unauthorized content. Like, for example, if I'm searching for something and I search for 4 or 5 times, the application or the server should not get crashed. This is not the intention of developing the software. So there are 2 aspects to this first point. Software should do what it is supposed to do and shouldn't do what it is not supposed to do. Then coming to the second point. So checking the product Okay, so second point is systematic way of finding the testing. So there is a process. Okay, so if we have given something that, okay, fine, you are responsible for the quality of this application or software. So how we should go about it? How should we improve the quality? By finding the defects and fixing it and retesting it. Okay, so this is the second aspect. We should learn the techniques involved in finding the bugs, how to find the bugs. So it is a systematic way of finding the defect in software so that it can be fixed before the product or application is released to the user. Software testing is an essential part of software development lifecycle. Any software that is being developed in the market, quality assurance, or we call it software testing also, is an integral part of. We cannot do away with that, because there are some things which we can see and predict in our daily life, but software is something which is not visible, which is in the cognitive space. So there are a lot of issues that we never know it will come. So that's why software testing and quality assurance is a very important aspect, and it cannot be do away with the from the software development life cycle. So by finding and fixing the defect early, software tester can help to ensure that the product and the application are released with a high quality. So I will tell you what happens when the system is not tested properly, and if the system go to the market without being tested, or buggy product released to the market. What happened? I will cover in one slide. It will give you a very good understanding with just few lines. So coming to the benefits of software testing. So software testing help to identify and fix defect in software, which can improve the quality. This can lead to a better user experience. User feel that, okay, this is very easy to navigate product, and we are able to perform our function or transaction or whatever functionality it is having very easily. So you will be having a good reputation in the market. So it reduces the cost by finding and fixing the defect early. Software tester can help to reduce the cost of software development and maintenance. This is because it is very very expensive to fix the defects after the software has been released. When it is went to the market, it involved a lot of cost in fixing the defect, and you will get sound functionality because of software testing. So software tester ensure that the software comply with the requirement. So whenever the software is developed, first the requirement is collected, and then according to the requirement, it is designed. So we have to ensure that the software work according to the requirement. It shouldn't be otherwise. Otherwise, it will having a very bad impact on the business and the reputation of company in the market. Obviously, a bug-free product is very easier to use, and user feel better, improve the software user experience, and make software more user-friendly. Coming to the performance, which is our topic today. So it can help to identify and fix performance bottleneck in the software. Bottleneck means a place where an area which is causing slowness in the system, or because of that area or that functionality or that particular scenario situation, the software is not able to work fast at the speed. For example, if we are using internet, if it is very slow, it is very irritating. Similarly, if we are using an application, if it is working very slow, clicking on the button, it is taking 20 seconds or 30 seconds, it is very irritating. The studies show that after 3 seconds, the user start to lose its focus and switch to another application or another tab or another window in the system. So it will cost revenue loss to the business. So it is very important for the software to perform as expected within the expected time. If it is taking a lot of time, it is very irritating, and then people will lose the focus on it. Can you confirm which slide you are viewing? Can just someone from the audience?
Why SQL testing?
Oh, okay, good enough. Actually, it is stucking on my side. Okay, can continue. We are good. So why SQA is important? So testing or software quality assurance is important because software bugs could be very expensive and even dangerous sometimes, and it can cause monetary and human loss. The history is full of such examples. So recently there is an event happened in Feb 2023. There was a demo for new Google chatbot, and in that demo it shows incorrect or inaccurate information in the promotional video. So because of this reputational loss, Google, which is a company of Alphabet Inc. in USA, has lost around $100 billion in the market value in the month of Feb itself, this year itself. So you can imagine like the cost that it will incur to the company when the software or the bugs shipped to the market. Similarly, Nissan has to recall 1 million cars. Another example of F-35 fighter plane, it fell victim to the software bug and it is unable to detect the target correctly. Chinese airlines in the year 1994 crashes due to software bug, which caused life of 264 innocent people. So this is the impact. This is the impact and the loss that can happen due to issues in software. So these are all the issues. I'm not going through all, but from these few examples, you can understand the impact. So how important the software quality assurance is in overall software development development process. So here is a general rule. This is not very specific. This is a general rule. So this is the financial cost of a software defect. This is a general rule to calculate cost of software defect. So if, for example, I will give you a very simple example. If a defect costs 1 unit, for example, if a defect costs $1 to fix in the requirement phase when the software is being designed, it costs $10 to fix the same defect in the testing phase. So, and if it goes to the production, it will cost $100. For example, if someone can fix in $1,000 in the requirement designing phase, it will reach $100,000 to fix in the production phase. So this is the kind of impact. Since the software testing, people do not take it very seriously. It is not considered as a very thankful job, but the impact is very huge. We have worked on a project where our clients told us, let's see, this is the product which is being used by these many number of millions of users. And if something went, some bug went into to the user or to the production, imagine what will happen, like at what scale it can create havoc. So testing is a very important integral part of it. And this is the diagram. This is a typical software development life cycle, and software testing is the fourth phase in it. So it has evolved a lot, and with agile practices, we are now started with the QA from the planning phase. So now we are like in agile, the QA is involved from the planning phase, from the first phase. But this is the very generic example that first the planning is done, designing, then implementation code, then it comes to the testing for testing and integration, then goes to deployment and then maintenance. So this is the cycle. So the earlier in the cycle, we catch the issues and fix the problems, the easier it is for the user, and it will save the cost to the company. Save cost and reputation to the company. So type of software testing, I have broadly classified into two types. Functional testing, describe what the product or the software does. It can be understood as the testing all features that appear when a user opens the application. So whenever we open the application, whatever see on the landing page, whatever buttons, whatever tabs, links, and forms, whatever we can see on the application, it is the functionality. Okay, testing that is called functional testing. And here we validate the software against the application functional requirement. So at the time of designing, requirement is written, you have to match that application is working according to that or not. It is kind of a guideline. Requirement is a kind of guideline which we should follow. Okay, like example, we are constructing a house and we got the plan on the paper, and how we test that the building is properly constructed or not by looking at the design. Okay, this wall should be this fit, this wall should be this fit, and this is the height, this is the room size. Okay, similarly, when we are building the software, we have the requirement, and if it matches the requirement, software matches the requirement, that means that it is a quality software, and the quality of software is good, it is built according to the requirement. Okay, so this testing check user interface, the components that we see on the screen, APIs that communicate with the server, database that hold the data, client-server communication, and other functionality of application render test. So these are the example of functional testing. Okay, so the topic for today is performance testing, which is a non-functional testing, which we cannot see in the application when we open the application. Okay, so coming to the non-functional type, so it can be understood as testing all the features that are outside the application or non-functional aspect. Non-functional testing check the performance, reliability, scalability. Performance, we understand the speed at which the operations are performed. Reliability means that application is very reliable. It shouldn't be like that today it is working, tomorrow it is not working, or few hours it is working. Like we know, like a lot of sites which are broken, then they lose the business and they lose the customer actually. And the scalability, that user should be able, the application should perform when the load is low, and it should be able to perform when the load is increasing also. For example, a system is designed for 50,000 users. It should be able to perform from 1 to 50,000 users, and it should be scalable even further. So this is the example of non-functional testing. So these are obviously there are a lot of many variety of non-functional testing, but here I am just concentrating on the few which are important: performance, load, stress, and security. Security is a different aspect, and it is altogether a different field of software testing. Today we are focusing on performance, which is very much similar to load and stress. There is one more called spike testing and endurance testing. So that also I will cover very briefly. So till here, the point to cover all these is to understand where we are coming from and where we have to go. So we have started with the basic software testing, and now we come to know that what kind of testings are there, functional, non-functional, and what under which category the performance and load testing fall under. So performance testing, to define in simple words, ensure software application perform properly under their expected load. So it is type of software testing that evaluate the speed, scalability, and stability of an application under a given workload. So speed means the speed with which the application responds. For example, we are clicking on a button, we are clicking on a link in a web page, how much time it is taking to load. Scalability means, again, it should be able to handle the user across the range from 1 to 50,000 and till whatever load application is designed to. And then stability. So the goal of performance testing is what is the goal? Why we are doing this? Again, to identify bottleneck, measure system performance, and ensure that the system can handle the expected number of users or transactions. Bottleneck is again the problem area. The whole purpose is to find the problem area and resolve it. Measure system performance, that how the system is performing under 10 user and how it is performing when the user load is more than 10,000, so that we can handle it. Okay, so again, now comes the type of software testing. So performance testing. So it is broadly classified into load, stress, and endurance. Load testing is done to determine how well a software application performs under a specific amount of load. So this is as per the requirement. Okay, for example, I have designed my application to to work with maximum 8,000 users or 10,000 users. Okay, so you could test how many users a website can support before it started to slow down. Okay, so it should perform till 8,000. I have designed my application for 8,000 users. It should be performing properly or with proper response time. Okay, the example is verifying. Example of load testing is verifying that a website can handle 1,000 concurrent users without experience any performance degradation. Okay, then comes the second part, stress testing. This type of testing is designed to push the software application to its limit. For example, I have designed the application for 10,000 users. Now I will go to 10,000 and 10,001 user and see whether it is completely breaking down or just slowing down the performance. So these are the things we will verify in stress testing. Running a example is running a stress test on a web application to see how it behaves when there are more users than the application was designed to. Okay, I have designed my e-commerce site for 50,000 users and I'm running a sale. What will happen when the user exceed 50,000? Okay, so one scenario is complete system breakdown, or all the users are experiencing slowness. Both are bad scenarios. Third one is the person who is who log in after 50,000 users shouldn't be allowed. There should be handling mechanism. Okay, so that all these 50,000 users for which we have capacity, they are able to make all the transactions or all the purchases or all the search or ordering, they are able to perform. So stress testing is done for that, going beyond the limit, beyond. And then the third part is endurance testing, is a type of load testing that tests the system ability to handle sustained load. For example, I'm running a sale for 5 days. So I expect that continuously there is a load on my server for next 5 days. So for that, we have to test the application beforehand, so that I run the test that, okay, I will be getting 50,000 users daily. At daytime, I will get getting 40,000, and at night time, I will be getting 5 to 10,000 users. Okay, so I will design my test like this and run it for 1 week, so that I am able to test the actual scenario that my application is going to face when there is a when it is on the production and where there is a sale going on the e-commerce side. So example is testing a software application to see how it performs over a period of 24 hours or 48 hours or 1 week. So this is the endurance testing. This is a long form of testing which will run for few hours or days. Okay. So how we will perform these testing? There are a number of load testing tools available in the market, both commercial and open source. Some popular tools are Apache JMeter, LoadRunner, Gradle, NeoLoad. There are a lot of tools, but the most popular and the most easy to use open source, like there are a lot of benefit of this tool, which is called JMeter, Apache JMeter. LoadRunner is also very popular. It used to be the market leader, but since it is a license, and they charge it very heavily, so it mostly for performance these days JMeter is being used, and it has a very good integration with the DevOps, with the programming languages, with different kind of, even it has an integration with the Selenium also. So you can integrate your Selenium script with this and it will run the performance test, and it support variety of tools. Okay, I will be covering all those in this slide. So Apache JMeter is a open source software. It is a pure Java application designed to load test. Okay, along with that, it can test functional behavior also, along with measuring the performance. It can be used to simulate heavy load on the server or an object to test its strength or to analyze overall performance under different load conditions. So what all we can use this tool for? So we can use for different applications, server protocol types. For example, for web application, we can use for websites, for which it support HTTP and HTTPS protocols. Then for APIs, we can use REST services, web APIs. Then for FTP server, database request, mail client also. So these are the few. It has IDE, which look like this. Okay, so this is the JMeter IDE. I will give you a very brief detail of this when we come to the result part. This is the result of execution. Okay, so this support variety of protocol. It has IDE. It has a recording capacity and building and debugging capacity as well. And we can at the time of development, we can use IDE. And when we are running the test, since the IDE is resource heavy, it consumes memory, we can have this CLI mode, command line mode, from where we can run this. It has a complete and ready to present dynamic HTML reporting, and it can integrate with the third-party open source libraries like Maven, Jenkins, other tools as well. Okay, so these are just few. And so what are the example scenarios? So I have mentioned that we can use it for all these things. So just for our understanding, so we will cover just these few, even though there are more also. I'll just try to cover in 2 lines so that you will get brief idea of how it can be used in different areas. So web application. So for this, we can test the performance of web application by simulating large number of concurrent requests. So for example, if you get a scenario to test the website, which is expected to get a load of 1,000 or 10,000 users, how will manually you test it? So you cannot have like 1,000 instance of browser in your machine and clicking on each and everything. It is not possible humanly to test that. Or even if it is very expensive to hire all those like 100 people who open a browser, 10 browser or 100 browser to send this many requests. So the easier way out is to use a performance testing tool and send the request through that 10,000 requests. You can just we can record or develop our test and just send these many concurrent results, and it will capture the response, whether it is showing the proper response or not. If the response is proper, test is successful, and it will record it in the result. Then at the end, it will give you individual as well as consolidated result. Then coming to the database testing. So here we can send large number of concurrent database requests. Similarly, we can send large, I will show you the example of API that we have recently done for performance testing. So there we send around a few hundred requests for API on the server. Initially, server was breaking, then later our development team fixed it, and then it is working fine now. So then we have like mail server also. For example, you want to test mail server, it can send large number of concurrent email requests also to the recipient. So these are few examples of what we can do with this tool. So here is an example of the result that we have for the result of test that we have conducted some time back. So I have this get host details API, which fetch the send the request to the server and get the detail of all the hosts available in the pod, in the infrastructure. Okay, initially we start with the 10 user, then we gradually move to 100, 350, 700, see the performance of the system, and we move till 1,500 users. Okay, so initially what we found, there were no issues, but at the 1,500 users level, when we are sending 1,500 requests to the user at a time, we are getting 7% failures. So with this, we are able to make out that, okay, our system is able to handle request somewhere between 1,000 to 1,500. Okay, so how do you read this? Because till 1000 level, we are getting only 0% error. But beyond that, we are getting 7. So we'll, as of now, we'll consider that, okay, we from these results, we can certainly say that our application is easily able to handle, or our API server is able to handle 1000 requests at a time with zero failure rate, with 100% success rate. Okay. And here in these 3 columns, average, min, max, average is overall time these 10 requests took to complete the request, and this is the minimum time and the maximum time. Okay, so, and this is the throughput is the measure of performance. So throughput is the number of requests successfully handled or unsuccessfully handled by the API server within second. So when we send the 10 requests, it handle 1.9 requests per second. Gradually we increase to 1000. There it is showing, there it is handling 43 requests per second without failure. Beyond that, it is giving even better result, but this is with failure. So we do not consider this result because it is not giving us the clear picture. We want success result. So this is the measure of performance. So okay, so once we get the performance, we analyze the result. We observe how application is performing, or which API is performing which API is performing better under a progressive load. So here is the example of few APIs that we have tested, and here we found. So last result we are not including because it is an error result. Before that, all these bars we will consider. See the behavior of these 2 applications. If you see the first 1, 2, 3, 4, 5 bars, we see the performance is increasing till 700. Beyond 700, the server is not able to perform better. Okay, the optimal performance, that means the optimal performance for this API on the server is 700 users, and for this 1000 users. So this is how you need to test the application. You need to read the result, and you need to observe and give the result conclusion to the development team, or the development manager, or to the overall project coordinator. So this is what we have to start with, basic of software testing, and then this is the end. This is what we have to deliver. So this is one full life cycle of the, and you have to report this as well, that okay, when I am running these many users, 1500 users, I am getting this error, this many percentage of error, and what is the error? That is error you can find from the tool. So we started with basics, and we concluded with the observation that we have to give to the development team. So what development team will do? They will either increase the capacity, or they will try to find out where it is, what is causing these failures. That is up to them to debug and come up to us with the solution. Then we retest and try to give them the retest result and compare with this result, how it will perform. So I hope you will be able to understand this very basic of load testing, execution, and this result observation, conclusion. So the learning path. So these are the 3-step learning path for performance testing, which we have covered in these slides as well. Software testing basics, in which category performance testing falls, non-functional testing. Okay, the basic concept of performance testing, like load, stress, endurance testing. These are the different variety of performance testing. Then the last part is tool part, and then the analysis part and reporting part. So these are the official resources which I like available on the internet. If you want, I can share this in the chat window after concluding the session. And these are the non-technical skills which are required to become a software tester. So software testing is not limited to very one particular area. Actually, it is a part of software development life cycle, and it is applied to any domain or any kind of software that you are developing. And software testing doesn't require very in-depth technical knowledge or the coding knowledge. If you are just able to understand the software as a user, and if you are able to think as a user, how the user will think and use the software. For example, all of us in our daily life are using a lot of software, banking software, social media software, job searching, for bill payments, for shopping. All these are the variety of software, and all are having a testing team, and all are having a QA. So software to start, or to, if you want to pursue your career in software testing and you are not interested in very in-depth technical knowledge or coding, you are not very much well versed with the coding, or you're not comfortable with the coding, but you love software testing and want to get into the software industry, this is a very low barrier entry into the software industry. Okay, and there are a lot of jobs available in the market for people who are having 1 to 5 year experience, or grads, college graduate, who are a little bit well aware of how to use the software, that everyone must know if you are from the engineering background. So these are the skills like analytical skills, communication skills, attitude, and passion to learn. Like every software is different. Even if you are working for one supply chain software or one e-commerce software, if you are moving to another company, for example, if you are working for Amazon, testing their software, moving to Flipkart, although the flow will be same, but internally how they are interacting with the customer, that is different. So if you keep on learning different aspects of the software, you will become very important integral member of the team, because a tester is because the tester got the opportunity to test the all aspects of the software from end to end, whereas the developer used to develop mostly on a very particular area or one module. So what I have seen, that those who get into the software testing, they become PMOs, or they got into management because of their overall knowledge. So this is a very good field for those who are not very much comfortable with the coding, okay, and who are not very much into technical. And actually, this is a very good field to enter into software industry for those people who are from non-technical background as well. So these are the things. So these are the skills which we need in other jobs as well. So this is not very something which is very different or very difficult to attain. This is all about the attitude and the approaches that you need to learn to get into the software testing. So here are few skills that technical skills, I will say, you need as a software engineer or performance tester. So you have to have the knowledge of software process, and had to have good hands-on experience on performance testing tools like JMeter, because if you are getting into the performance testing, first you have to know the basics. Then when you come to the performance testing, you have to have the knowledge of tool, because very rarely we do it manually, very rarely. But for that also we need some other tools. It is good to, if you learn some good performance testing tool, it will be a very good it will give very good weightage to your resume. Basic knowledge of Linux, Windows commands, knowledge of hands-on experience on test management tool. This is also a very simple tool, defect tracking tools. Test management tool is a tool where we put all our tests, what we have executed, making it successful, pending or pass, raising bugs. This is just kind of data entry, just managing our test there, so that we will know what is the status and where we are standing. Then, and defect tracking tool. This is used to track the defect. If there is any issue, we log the issue, and then it goes to developer for fixing. Then again, it come back to the tester. If it is fixed, we can close it. Otherwise, we reopen it. So these are very simple, basic tools. Anyone can learn this. But only first point, performance testing tool, it will take some time. And approaches also you can, processes also you can very easily understand, learn, and practice. Then The in-demand roles, there are several roles in demand for software testing as companies continue to place a high priority on quality and reliability of their software system. Some of the most in-demand roles are software test engineer. So this can be entry level also. So most of the college grads who come into the industry first, they get entry level role, which involve initially they will get the test cases. They just execute the test case, report the defect, and verify fixes. Once you get the experience, then you will get the responsibility for designing and executing test plans, test cases, as well as analyzing and reporting on the test result. Next comes the very popular role, automation tester. So it focuses on using automated testing tools. Again, here you need, so whatever you perform manually, like opening a web page, logging in your credentials, checking if you are able to log in, the same operations same steps can be automated using tools called Selenium. And there are other tools as well, but Selenium is very popular. So if you want to get into the automation, again, you need to learn a tool like JMeter for performance, similarly like Selenium for this functional automation. So like performance tester we already cover. Then security testing, there is another field. Then comes test manager, QA or test manager. It is responsible for leading and coordinating the testing effort of a software development project overall. So this involved like communicating with the development team, requirement team, and tracking the progress, updating the team. So all these management tasks are involved in the test for the test managers. Then there are other roles as well, like mobile tester, DevOps, QA engineer that I'm not covering here. So I just mentioned so that you have that in the mind as well. Now coming to the opportunities. So these are the two websites, LinkedIn and Naukri. I have find out today itself, and these are the results from today's search. Like for performance testing on LinkedIn, I see. So this is the data only for India. Like on LinkedIn, I see there are more than 3,500 opportunities, and on Naukri there are more than 18,000 opportunities in the market. And most of them are for 2 to 5 years, 4 to 8 years experience. So if you have a little bit of experience, you can get into this. So there are a lot of opportunities. Then okay, so that's all we have in this session, and we are opening it for Q&A. If anyone is having any question, I will try my best to answer from my experience and understanding and knowledge. If I'm not, then I will definitely get back to you. You can connect me on my email ID, which is mentioned here. And with this, I'm opening the session for audience. I'm sharing the learning resource in the chat window. All those who are interested can check it there. Yes, Tanveer, you can definitely learn performance testing, but before that, start with the basics of software manual testing. So once you are done with that, you can start you can start learning performance testing and this tool. Sorry, I forgot to show you the tool that I told you. Now, this is my contact. If you have any query, you can mail to me at this email. So Tanvir is asking, can we learn performance testing without coding? Yes, definitely we can learn. So, but just start with the steps that I have mentioned here. Learning path. You have to follow the learning path. Anything for any technology or anything, if we are starting, we have to start with the basics and then gradually move upward toward the advanced topic in that technology or tool. So follow that. So this is the JMeter IDE. Here we set all the parameters, and then, for example, this is the login. It is requesting for the login, and it has few steps. I'm not going in all the details. It is requesting the login. Once it login successfully, it will send the request like this. So this is the API. It is sending this request and getting some result. Okay, once the so this is the result for this individual API. So what does this sample mean? Sample means there are 25 logins. Sample means users, like 25 users log in, and 25 users after login send this get 10 requests. There were no errors. All the requests were successful. Then what is the throughput? How does it perform? 1.2 user per second is the performance rate. It is able, this API server is able to handle 1.2 users per second. Okay, similarly, there are other requests. And if we want to see the overall picture of, then we have this. Overall, we have sent 25 requests for each API. Overall, to 625 requests we have sent. Then what is the minimum time for a request, and what is the maximum? What is the average time? What is the error percentage? Error percentage is 0. This is the individual performance. This is the overall performance of the result. Like the system is able to handle, API server is able to handle 26.8 requests per second. So when there is a change on, when there is a system upgrade, we again test the same test and we compare the result with this throughput performance. And if someone want the details, result in detail, we can tell them about the all these minor details, drill down details like received KB per second, sent KB per second, data sent per second, average byte transacted. So all these are the, and it has different type of results like graph result and this summary report. So once you start working on that, you will start using this. You will find out the features about this tool. So this I just show from the live project, and we have done it recently, like a few weeks back. So this is for just for understanding purpose. So if there are no questions, can we conclude the session, Dr. Saab? Dr. Saab, can we conclude the session?
Yeah, any last question from the audience?
No, sir.
Okay, so we got
Anyone else?
one question. Yeah, we got one question in chat window. Can non-IT people with around 4 years experience start getting into the field? What's your suggestion? Yeah, definitely. So as I mentioned, it's a low barrier entry into the software industry. So they can like very well like get into this software testing and software performance testing. In fact, a lot of people I've seen in my career, like when I started my career, I had one guy with me in the training batch who switched from other field, who was BCom and doing something else into sales or something marketing. He learned, he gave time, and then he grew with us. There is no difference once you get into the industry. You perform, you have talent, then you are unstoppable. You are learning, you are growing. Then even if there is some issue in one place, you will get chance and opportunities at other places. So as I have shown you, like there are thousands of opportunity in the market. There is another question. Can I have a recording of this entire session? Yes. So Dr. Saif has already updated the URL for that. You can watch it. And I have mentioned my email ID in the chat window. If you need anything, I can guide you on that. Yeah, I have mentioned on the top. It has in the learning resource. If you go to the GitHub link that I have mentioned, it has tutorials, like video tutorials as well. And there is one very good group on LinkedIn. Some members are very active on that and they are very knowledgeable. So if you get a chance, go to this performance testing group LinkedIn. The link is also mentioned. So when you go there and see the questions, what kind of questions people are asking, and these are very practical and issues that are in the market people are facing, and these are the things on which people are working on. These are being currently used in the industry. What kind of problems they are facing, what are the solutions, in which area we can use JMeter, what are the issues people face. If you go to that group, LinkedIn group, I have mentioned on the top. If you want, I'll mention it again. So if you will get a lot of learning just by reading the problems and seeing the solution, what problems people are facing and what are the solution for their problem. And one more channel is there, automation step by step. By step, if you search this on YouTube, there's a guy called Raghav Pal. He has also explained it very beautifully. But these are all the basic things. When you come to the industry, you will be facing very different kind of scenarios in every project, every release. So, and ideally, people look, if you have a fundamental knowledge, basic knowledge, then you will be able to handle all kind of scenarios. So that's why I always suggest people to have very good fundamental basic things done. Then when we interview also, we look for very basic things. If a person is able and he has a good knowledge of basic fundamentals, then he can go ahead, like he can learn other things also. But if the fundamentals are weak, then it is very difficult. Like people keep struggling. Is there any age limit to this profession? No, there is no age limit. If you are eager to learn and practice and perform, then there is no age limit. Like people of all ages, even I've seen like people late in their 40s, some people in their 50s start coding and they did very well. But you have to find out like what you are good at. And if you don't know, there is one way to try different things and find out. But don't delay. Don't delay thinking about whether I will be able to do this or that. Don't give too much time to yourself. Just if you are not able to make up your mind, just start doing something. Try something, try different things. 2, 3, 4, 5 things, you will get one thing and then stuck to it. Actually success comes when you stuck with the things. You will give time. So the more time you are spending in one field, the more chances of getting success you will get. So it's directly proportional. The more time you spend, and the more chances you will be having of success in that field. Okay, so I think there are no more new questions. So thank you again, everyone, for joining this session.
Thank you, Naazir bhai. It was very well session, and I hope it will be useful to all of us. And thanks to all the audience also, inshallah. So you'll find the recording at the given URL after a few days, inshallah. Okay, Naazir bhai. We'll speak soon, inshallah. Assalamu alaikum.
Wa alaikum assalam.